Hello and welcome to my talk. I'm Stefan Höller. I'm from company Eurofunk, and I want to talk with you today about how to version a library and how to do it effortlessly. So we at Eurofunk had a problem we faced some time ago. We have a product cycle of 15 years or more. We have 50 plus front-end developers working on our software, and all of this code is contained in a large repository, in a large monorepo. And many of those components that we use and use again, like buttons, accordions, selects, these kind of basic components are turning into God components. So what is a God component? Basically, that is a small thing that does everything. So here I have a select or drop down, and I've listed some features that one of those selects could do. It could be a combo box, a search bar, it can do single, multi-select, it can do pagination, lazy loading, virtual scrolling, and a bunch more. And for every feature that we added to such a component, well, you can imagine it got buggier. And we fixed it, we added something, we broke it, and the cycle repeated over and over again. This was kind of tedious and hard to maintain, so we kind of made a decision. We wanted to create a standardized component, like many other companies do. We want to have a well-defined scope. We want this scope to be easy to use with an API which everybody is able to understand. It should be well documented and, of course, reusable over potentially multiple products. What we opted to use for that is, one, we designed that in Figma. So this is our mockup tool and how we define and the looks and feels of how this should live in the product. We used Angular to implement this, and we used Storybook in order to document and showcase our library. The next question what we had is, where do we put such a thing? Do we put it again in our monorepo that is already quite large? It has the benefit that it's easy to integrate, easy to access, and the drawbacks I already said. It's easy to manipulate and easy to change, easy to add one little feature that nobody needs. And what would be the other approach? Well, we could use a separate repository in our version control. We could then potentially have the benefit that we can do everything from scratch. We have no baggage. We have no dependencies to other products or anything like that. It is resilient to change. So not every little feature goes into that automatically because it needs to be crafted, planned, and designed. Huge drawback is, like the advantage, everything is from scratch. So it's a lot of development effort to do such a thing. It's hard to integrate, and well, we did try to reinvent the cycle, the bicycle again. But what did we choose in comparison to that? We chose the multi-repo because we wanted this resilience. This was our main factor. So next question is, who should be responsible? It should be driven by someone who has technical insight, which would be our tech leads. It should be designed by someone who has experience with UX design, which would be our UX team, and implemented by someone who knows Angular and all the tooling around it, which are our front-end developers. The next question might be, who should maintain it? Well, here comes some tooling. We have GitLab internally. It allows us to store all our code like usual, and our pipelines to automatically check everything and how the quality of our code is. And the other tool that we want to use is Renovate. It basically tells you what dependency you use in your component library or any library or project, which is out of date, and suggests that you update it. So there is no manual periodic task needed for, do we need to update this library? Do we need to update that library? No, it's just there. Renovate just creates a pull request for you, and you have to have a look at it if it's okay or not. Maybe you have to do some manual adaptations, but very often you just hit merge. Okay, with this question answered, what's next? Well, as we want to do a component library, we want to put it somewhere. And how do we put it? We want to publish it in our package registry. And who should do that? I'm not sure. Does some person do that? Do we have someone who talks to every developer if we now found out the feature that is worth publishing and we decide for a new version? No, we didn't want to do that. We wanted to automate it. But how? Well, I want to introduce you to our new, or not new, to our tool that solved this question more or less for us, which is Semantic Release. A small node package that you can add to your project, no matter which project. You just have to live with the fact that you add a bit of Node.js. But what does it do? It basically analyzes all the commits that you add since your last version was published. It determines the level of version which needs to be updated. It creates a version tag. It publishes it to your package registry so that all your projects that want to consume it can do that very easily. And it creates a changelog based on your commits. This is very commit driven. It seems we kind of need a format for that. There already is. There is an Angular message format, commit message format, and it is very easily structured. Typically, you just say, yeah, I fixed the button layout, hit commit, and be done. But here, we kind of need to define a type, which is a bug fix, a feature, a refactoring, whatever, a build. Then we have a scope. So what are you touching? Your button component, your accordion, your select. A short summary like usual. I fixed the button layout. And of course you can put down there everything you want. Let's have a look on how this could work. So one little fact that I didn't tell you about until now was that Semantic Release is based on semantic versioning. So for a quick recap, we have 3 different levels for semantic versioning. One is the patch level, where every of your bug fix and small little changes will end up. Your minor version, which is about all those features that you add. And a major version. This major version is typically misunderstood. It's not about some brand new whole rework of your product. It is about breaking changes, breaking the API. So to a developer or a consumer of your library, these kind of version updates always tell you what might change and what you need to deal with. So let's see. We have here a commit message, fix, resolve button click issue. That's a bug fix. So we update the version to 2.1.6. We bumped the patch from 5 to 6. Next thing is we add a feature. We add an accordion component. We update now the version from 2.1.6 to 2.20. What about this feature? It is a feature. It streamlined the button API so that the developers can easily use it, but the API was changed. So we need to declare that as a breaking change in the text body. And the component was a mess beforehand, so we needed to simplify it. So what do we need to do in order to make semantic versioning work? We need to update the major version. But also a small thing is that typically a refactoring shouldn't change anything. Here we refactor a mixin shouldn't do much, but in the same time we deprecated the old mixin. And the deprecation also needs to lead to a new version. So we update the minor version as the API wasn't broken. So, and to demonstrate that, I want to show you a little demo. First, we head over to the Effortless library or the app. Let's show you the use case first. So here we have an app. It is a counter, small counter. It has a button here, count, and a reset button here. Not much to it, but something's off. I remember that we use here, here, and here all those components from our component library, from the Effortless component library. But the component should look differently. Seems like we have a bug. Let's try to fix that. We head over from the counter app to the Effortless library. We see here we have some global styles defined. Nice. It defines colors and a gradient, stuff like that. Looks good. We have a barrel file. We export the styles. And now we head over, but I'm questioning why does this not work? And I did some digging beforehand. We have here a package JSON which doesn't export those assets, the styles. So I quickly head over and let's fix that. I copy that. I put that here, take the styles. So now we have the barrel file and the style SCSS as an asset. And hopefully that should fix the problem. What we then do, we add changes. Now we need to come up with some smart message in order to kick off semantic release. This is not necessarily a feature, it is a bug fix. So we fix and we add global styles as assets. We commit that. And now I'm a bit brave. I push directly to main and let's see what happens then. Nice. Let's head over to GitLab where we should see a pipeline which has been triggered. Great. Okay, here when I zoom in, you see that my commit is here and it triggered a pipeline which contains a step for installing all the dependencies. The other one is building the library. And the third one is publishing it. And here is an interesting step, but we will look at that in a minute because the pipeline takes a while. In the meantime, I can show you something. basically we have here the definition of our jobs. I will make that a bit smaller. So here we have the build job. We decided it to be at the stage of build. We run the build script, and what we do here, we take the output that was generated in the dist folder and provide that as an artifact to this pipeline. Because this artifact, the generated output of the library, needs to be reused by our publishing pipeline. This is started at the release stage. And what do we do here? Looks very simple. We just run semantic release, which needs the install job from the dependencies and the output from the build library. And that's all. Let's see what the pipeline says. It's building the library and instantiate a Docker image. Typically, those pipelines take the longest because of starting Node.js. And what we expect then, after this pipeline has been created, or after the pipeline has finished, semantic release has looked at the commit that we added. It should generate a new package on the decision on that, and a new git tag with the version, and it should add a changelog. And then after that is done, so the building is done, we have here now an artifact that could be downloaded, but we won't do that now. We have here a release stage, which also needs some runtime. I think we will speed that up in the cut in post. Oh, success. So what did it do here? We have here something interesting. So here's the output from semantic release. It publishes. It should actually look at the commits. And here we have the commit. Okay, so here we have the previous git tag. It was 2.4.2. Since then, that release one commit was added. It analyzed the commit and decided that the fix commit message would create a new version, which is of type patch. So it will create a version 2.4.3. And below we see that it published this under the effortless versioning, effortless lib at 2.4.3. Let's see if that is actually here. We have a registry under deploy, a package registry. And here we have effortless lib 2.4.3. And here under releases, we also have it. And it has created some release notes with our bug fix. Nice. Let's see if we can also use it. So here I head over to our counter app. I make that larger as well. I will now check npm update effortless versioning effortless lib It has now changed one package, yes. And we can see that in the package log. Effortless. Effortless lib, we use here 2.4.3. Okay. Now, what should happen now? After this whole release process, we fix the styles, the global styles, and in our app, we now need to use them. We go here to our app component. We import the styles from the library, and we execute the mixin here. We save. Then we should get a refresh, and voila. Now we got some styles. You see the gradient was here now added, and the buttons look now according to our design system. Yeah, so what do we learn from that? What has Semantic Release ever done for us? Basically, it cost me, while setting up this demo, 50 commits of pain, because deployment is hard and hard to do. Another problem is I cannot make up any random version numbers anymore. I cannot negotiate with anyone. This is dictated by the changes that I do. I need to think about my changes because I need to write careful commit messages. Another problem is the pipeline tells me when I'm wrong, and it will tell me that very often, especially if I enable commit message linting, which I recommend everybody would do. One thing is I don't really need to maintain Semantic Release after it has been set up properly, because after that they avoid breaking changes quite a lot, and it very often just works. I don't need to think about versioning anymore, which is great. I can just release it. As you just seen, we generated a new package version and I didn't do much. And I can update my project step by step because I have incremental development and not those large version updates that take forever to develop. And I can thus discover bugs more easily and isolate them and fix them. So how's our component library now? It has no God components. It has solid APIs, clear behavior. It is documented in Storybook and showcased. And the design of it is driven by dedicated designers. One thing I want to point out, yes, this package is based on Node.js, but it has a bunch of integrations for other registries. So you can not only update it or upload something to npm, but also to Docker, Docker Hub, or for Rust, for Python, for Java with Maven, or you can also maintain your own extensions for Firefox, Chrome, or VS Code. And a bunch of more, of course. Here are some resources that I used. There's, of course, the semantic versioning manifest, more or less. Very interesting to read. Then the semantic release side, the commit message format, which you would need to adhere here. And also the guide for the GitLab registry and integrating it. Well, that was all I wanted to talk with you today, and thank you.